Coming up on Dr. Kiki's Science Hour, we're talking about science fair projects with students at the Intel International Science and Engineering Fair. That's coming up on Dr. Kiki's Science Hour.
Netcasts you love.
From people you trust.
This is Twit. Bandwidth for Dr. Kiki's Science Hour is provided by Cachefly at CACHEFLY.com.
This is Dr. Kiki's Science Hour with Dr. Kiki, episode 46 for Monday, May 17th, 2010, The Future of Science. This episode of Dr. Kiki's Science Hour is brought to you by Squarespace.com, the fast and easy way to publish a website or blog. For your free trial and a 10% discount, go to Squarespace.com and use the offer code KIKI. Welcome, everyone, to Dr. Kiki's Science Hour. It's episode 46, and we're talking about science. That's no surprise there, right? Well, we've got 1 hour to speak with a number of young scientists, actually. I'm pretty excited about this show because this week is the Intel International Science and Engineering Fair, and it's taking place in San Jose, California this year. And there are over 1,600 young scientists from all around the world, ages, grade levels, 9th through 12th grade, and they've come and the projects that they have are amazing, and I'm lucky enough to be able to speak with some of them today about what they've done and what the journey to get here was like and where they see themselves going in the future. And additionally, we'll be speaking with Wendy Hawkins, who is the executive director of the Intel Foundation, and finding out a little bit more about the details of the science fair and how it takes place. So the Intel International Science and Engineering Fair is the world's largest international pre-college science competition. It's annual, and it provides a forum for, as I said, thousands of students. And they're from over 50 countries, regions, and territories, and they showcase their independent research. And that's the key here, is that it's independent research. And I have to say, it's not like the science festival that you might remember from when you were in high school. There aren't any volcanoes erupting some kind of red bubbly liquid, and there's not a lot of plants and food coloring. There's much more in-depth, detailed investigations into the sciences going on, from all the way across the board, from computer science and robotics to green technology to the biological sciences, nanotechnology, genetics, engineering. I mean, it's across the board. So let's get started with the students. Let's move forward. Let's see. And our first guest today, let's see if I can bring you in. Matthew Agam. It's nice to meet you. Thanks for joining me. Hi.
Nice to meet you too. Hi. So
tell me what grade are you in and where are you from, and let's just get started there.
Okay. I'm a junior at Beaverton High School in Portland, Oregon. So.
Okay, and is this the first year that you've done this kind of a science fair project, or are you?
Yeah.
Yeah.
This is my first year doing science fair projects, so it's pretty exciting. Able to come to ISEF this first year.
Yeah, that is amazing. What got you interested in doing a science fair project this year and getting into research?
Well, I started interning at a research lab at OHSU, Oregon Health and Sciences University, last summer, and I really liked it and decided to continue that into the school year. My teacher recommended I make a science fair project out of what I found, and so I did.
All right, so tell me a little bit about the project itself. The PR spin on it that we've been getting, which I think is kind of interesting, is that it's related to the war on terror and people going to war and a lot of the traumatic experiences that they might go through.
Yeah, exactly. I was testing for differences, for genetic differences in people's susceptibility to develop post-traumatic stress disorder. and obviously with the war effort going on in Iraq and Afghanistan, each new surge of soldiers that we send out there, we get soldiers coming back, with experienced trauma and ultimately develop post-traumatic stress disorder. And so, I investigated, what genetic differences made one person more susceptible to developing it than another.
And what kind of genetic differences are there? I mean, are there actually genetic differences that keep some people from having this experience?
I found that there actually were. I studied one gene in particular called apolipoprotein E, ApoE, and it's been associated with other hippocampus-dependent disorders like PTSD, namely Alzheimer's. So, it exists in 3 different isoforms. It's 3 different genotypes, and I found that different genotyped animals actually vary in susceptibility to developing post-traumatic stress disorder.
Do you have anybody in your family that suffers from PTSD, or was this something that, just became an interest of yours as you started doing work in a lab where you started working?
Yeah, I can't really say that I know anyone directly that has PTSD. But last summer, I came to the realization that this is actually a really big thing. I mean, there are almost 8 million American adults that suffer from PTSD now, and it's on the increase, and something needs to be done. And research with PTSD, especially the protein that I studied, it's a pretty new subject area, and I thought it'd be good to introduce that and be the one to take that first step, I guess, in my lab.
Yeah. So now that you've found that there is this potential genetic cause for people to become more susceptible, where do you see the research going? Are you going to keep involved in the research yourself?
Yes, I am. Because obviously there are many variables that can play into what makes one person more susceptible to developing the disorder, and those probably also affect the genetic differences also probably play a role in those variables. And I'd like to continue working in my lab and investigating this gene's effect on PTSD susceptibility. Ultimately, take it into the real world and help prevention and alleviation. It's an important thing to do.
And so as you're looking forward in your junior year right now, do you see yourself sticking with genetics? Is that a primary area of interest for you, or is it more disease research?
Not either, actually. I mean,
okay.
I've through my internship and my work up at the lab, I've more than just found an interest in genetics and disease. I've really found kind of a passion for research, scientific research, and it just grows. It grew on me, and now it's one of the bigger parts of my life now. I go into the lab every day after school, and doing projects, and analyzing the data, and reaching conclusions from the results.
What's your favorite part of it?
My favorite part is, I'd have to say, sitting down with my professor and some of the grad students in my lab after all the data's been collected, and discussing like what one thing means. Like what does this data point mean exactly, and how does that translate into like the real world, and just how can this help in the ultimate goal.
Right. So where do you how has this week been going for you personally at the science fair?
Well, this week has it's been actually pretty fun. There are lots of really nice kids from all over the world. I mean, I don't even know how many countries are represented here. Yeah. But I mean, obviously we've been getting work done, and I enjoyed presenting my research to the judges and to other students, and just the public. But I had a good time, with my friends here, and meeting new people, and it was really awesome.
That's cool. Have you made new friends from different parts of the country who you hope to, I guess, collaborate with scientifically?
Yeah, I met some kids from North and South Dakota, Wyoming, like Nebraska, and Iowa, and the Puerto Ricans are pretty cool, and the Colombians, the Lebanese.
Awesome.
I like them. Yeah.
It's good. Yeah, I'm sure it must be a really eye-opening experience to come from, from Portland, Oregon, and come to this kind of a mixing pot of just people from everywhere, just everyone excited about science and what they're doing.
Yeah, it's pretty cool. I mean, these kids, they all are very good at what they do, and it's really awesome to kind of have an inside look at, like the future, I guess. I mean, these kids are all going places, and that makes me feel kind of good and kind of a part of the bigger world community, I guess.
Yeah. All right. So one last question for you. Do you have any tips, or do you have any, I guess, for yourself or for any other high school students out there who are interested in trying to make it to the science fair, the Intel International Science and Engineering Fair? Do you have any tips or tricks or things that you're going to be thinking about doing?
Yeah, sure. I'd say one big thing for all high school students and really anyone out there is just to, be open to new things and, take every possible opportunity to explore a new area that you might not have found interest before. I try to just expand my horizon to like all the possibilities out there, and take every class I can. Yeah, I tried doing being a part of a research lab, and I ended up really liking it. And, I wouldn't be where I am right now if I hadn't have taken that step to try to open my eyes to the real world.
Yeah,
and what I can do, and yeah.
I think that's some pretty good advice. Thank you so much, Mr. Agam.
Yeah,
it's been wonderful speaking with you, and I wish you the best of luck. I know that you're probably going to be holding your breath along with all the other finalists until the awards are announced tomorrow, right?
Yeah.
Yeah.
Yes.
So good luck, and thank you. I appreciate your time.
Thank you.
Thanks. And that was Matthew Agam, and we're going to be moving on to our next science spectacular student. Let's see who we have next here.
Hello.
Hi, who do I have now?
Christie Fransworth.
Christie Fransworth, fabulous. Just making sure that I get the right lower thirds up for you.
All right.
All right. So, Christie, tell me, how old are you? What year are you in school? Where are you from?
I'm 18 years old. I'm from Paonia, Colorado, and I'm a senior this year.
And you're a senior this year. Have you been to the Intel International Science Fair before?
2 years ago, I came when I was in Atlanta, Georgia.
Yep, you 2 years ago. So, Did you try both last year as well? Is there a difference between, or was there no project last year?
I competed last year to come, but I didn't win to come.
It's pretty amazing that you've now been twice. This is pretty exciting. Tell us all a little bit about your project. What have you done this year that got you back?
Well, my project's a continuation from last year, and what it is it's a geothermal ground loop. And it's the idea right now all they use it for is heating your home. And it's my idea is to heat the home and use electricity at the same time with the device I built. And with my device and the results I got, if you ran it constantly for a month, you'd be able to power 80% of the average home's electrical needs and heat it at the same time.
Wow. That's pretty amazing. So let's dig into the basics of how this works. So you're using let's dig into the basics of how this works. You're using geothermal power, so basically hot water, right? Or heat from the earth, right?
Yeah, the water's warmed from the earth. Yeah.
Okay. So and then how does that work with the electricity to be able to meet the power needs and the heating needs?
There's this thing called a TEG, which is a thermal electric generator. And it's just like a little square that's like an inch, 1 inch by 1 inch. And it's not that thick that I was using. And what it does is it takes hot temperatures on one side and cold temperatures into the other side. And the temperature differential creates electricity. And then I had 3 different loops, pipes that I had. So I had a pipe, then I had 12 TEGs, and I had another pipe on the bottom. And then I had another set of TEGs, and then another pipe, is I had 3 pipes, and in between 2 of them, I had TEGs, 12 TEGs, and each pipe had a different loop source running through it to create a temperature differential so you could create electricity.
Ah, okay. So it's that differential between temperatures in different places that actually generates a current that the house can draw from. That's cool. So what got you thinking about this? I mean, it says here in the little press bulletin that scientists told you it could not be done. Was that part of the challenge?
Yeah, it was. I originally started because I wanted to make a difference in the world, and when I started my project, it was with the energy. I wanted to help with the energy crisis because it was when the price gas in America really went up at the time, and we thought it was going to keep going up. And so I wanted to find an alternative energy source that you could use as make one that already existed better or something totally new better. And eventually I came upon looking at a geothermal system because my library was putting it in, and I wondered if I was like, why can't we use this heat your home and create electricity at the same time? And I asked electric companies and geothermal companies, and they told me that it was impossible, that you can't use heat to create electricity. And I was like, oh man, there has to be a way. And so that really got me into researching it even more. And that's how I got into my project.
That's cool. So are you interested in engineering and continuing along this kind of a green technology kind of path, or what's your path? Where are you going now?
I'm going to Provo, Utah, and BYU, I'm going to BYU and Provo, Utah, this fall, and I'm going to study 2 majors in business and environmental engineering. Very cool. Very cool. So where do you see yourself in the, after college years? Way off in the future. I really don't know, to tell you the truth. I just, I want to do something like I'm doing now because I have a lot of fun with it. But other than that, I really have no idea. Have you been having a really good time this week? Is the science fair, what kind of an experience is the science fair for you? It's a lot of fun. You get to meet a lot of different people from around the world or even in the U.S. and meet new different types of people and experience things different than the environment you're used to, which is cool. And it's a lot of fun. That's neat. And is this year different from the other time that you came at all? Are there any major differences, or is it? I'd say it's way different for me, at least, because the type, just the town and the activities they decide for you to do are way different. I mean, they're still hanging out activities, but they're just way different types. Have you made any new acquaintances, any friends that you think you're going to keep in touch with? I have a bunch. I have a girl from Colombia, a girl from Hawaii, and then a couple others. Do you think? Do you get is there any? Do you guys have science conversations? Do you have engineering conversations? When you're hanging out, having your hangout time, what's the talk about? Is it the cute boys, or is it the science? What's going on? You talk about your project really briefly. Sometimes talk about your project, or you'll talk about science stuff, or you'll just have a normal conversation you'd have with your best friend about things that are going on or interesting things, or just when you're talking to someone. So it just all varies. That's cool. And what was the last question? I was going to see if there are any questions in the chat room for anybody. Yeah, there are some people in the chat room who are pretty astonished that nobody actually that people told you that you couldn't use heat to create electricity. That's a pretty astonishing thing to be said. Your research obviously showed that you should be able to, and that was the direction that kept you going, right? Oh yeah. Oh yeah. And is this something that is this something that you figured out all the parts and pieces on your own? Did you have a mentor, a teacher, a parent, anybody? Well, when I started researching, I asked a bunch of people, and asked a lot of people if they knew anything, and some people gave me suggestions and ideas that I searched up, and so there are some people that tried to help me, but a lot of it is just research on the internet. Right. Thank goodness for the internet. I think
I attended the Nobel laureate panel on Tuesday, and I remember at one point they mentioned how good the internet is these days. That once upon a time in the old days, we all had to go to the library and look in books, and it was much more time consuming.
Yeah.
Yeah.
The internet takes a lot of time now, so imagine a book.
Exactly. Having to go down book by book and figure something out.
Yeah.
Well, thank you so much, Christie. It's great talking with you, and I wish you the best of luck. Good luck in the competition.
Thank you.
Yeah. You're welcome.
It was lovely talking to you.
Yeah, it's been great chatting, and good luck in college, and do great things. Maybe I'll get to interview you again.
Oh, thank you. All right.
Okay.
Bye.
Bye. Thanks, Christie. And now we are going to be moving to the executive director of the Intel Foundation. I believe. Let's see. I have somebody else up here.
Hi, I'm Kelsi.
Yes.
Hi, I'm Kelsi Watanabe. I'm a 10th grader from Mililani High School.
Hi, Kelsi. It's great to meet you. Yeah, I thought Wendy Hawkins was going to be coming in, but I love to speak with you as well. If she's not standing in line, chomping at the bit, waiting.
I think she's here. You want to talk to her?
No. I don't know if she had a tight schedule. That's all That's all I was concerned about. But if they told you to come on up, that's great. Let's have a conversation. So, Kelsi, tell me. Let me see if I can get. There we go. I got you lower thirds. So tell me about your project. I actually was wandering around the floor of the festival on Tuesday morning, and I came across just this beautiful airship model. And I just sat there looking at it and just was amazed that that a student had come up with that and made it themselves. And this is yours.
Yes.
Tell me where this idea came from and what got it all started.
Well, basically, I was focusing on my last year's project, which was solar energy. But I didn't really like solar energy too much, especially what I was doing at the time, which depended on the heat from the sun. But where I live, it's kind of cloudy most of the time because it's raining off and on. And I figured by the time I actually had a working model up, it would be during winter time, which is rainy season in Hawaii. So I kind of was looking at other inventions I could possibly do for my science fair project. And I was just going over with my mentor, coming up with this huge list of inventions I could go over. And then this is one of the ideas that came up. And I love renewable energy, so I thought I'd look more into it, and I found I loved it. So this is basically how my project started.
And so with the renewable energy, in your case, what you're creating is a wind power generator. Is that correct?
Yes, it is. It's an airborne wind turbine.
Okay, tell us how it works.
Okay, so basically it's a dirigible, which is sort of like a blimp, except it has a rigid frame. Basically, it's probably going to be made out of carbon composite if possible, and have basically an envelope that's similar to a blimp, except it's going to be stronger because it has to withstand hurricane wind speeds. And then the rotor at the back is where all the wind is collected. It goes through the front of the aircraft, and it flows over the aircraft itself and then collects at the rotor. Then the rotor then turns the generator, which is at the front because it has to counteract the weight, and it comes down through the tether. So on one tether, there's going to be 4 of these, so it can maximize its usage.
Wow.
So it's going to be vertical.
What was that?
It's going to be vertical, so there's 4 vertically.
Okay, and so I've heard about people putting kites in the air for wind electricity generation, and so this is just is this just a different design to achieve a similar effect?
Yes, but it's also going to be at higher altitudes than a kite, because a kite is usually only 100 feet up, but mine is going to be between 15,000 to 30,000 feet.
Oh wow, really high altitude. Yeah.
So you're really hot.
Yeah. So what are the wind speeds like up there? Do you know what kind of winds they're going to be taking advantage of?
Yes, it's going to be between 100 to 200 miles per hour.
Wow. So okay, tell me about designing your dirigible. I mean, did you design this dirigible yourself and the model, or what were the principles that you applied to choosing a dirigible in the first place as well?
Well, as I said before, there's mostly a back of the napkin sketch because basically I was talking about blimps and dirigibles at the time with my mentor because we tend to go off topic sometimes and talk about random ideas.
That never happens. No.
Yeah, well, we're talking about just inventions in general throughout history, and dirigibles and blimps came up. So we're like, what if we put a wind turbine on this? So I looked more into it, and I was researching into dirigibles a lot, and I was researching into, okay, what kind of materials would be needed, what is available technologies that we have at the moment, and to try and see, do we have everything that's possible for this design?
And so then.
So then afterwards, I basically started just building it, just working on the model, and that took like a month or two to finish. And it was just a collaboration between my mentor and going over basically what's necessary for this aircraft in order to it. And slowly, one by one, the pieces added up together into what it is now.
Wow. So was there a lot to take into account in terms of designing, like, I guess for the wind forces that it would be up against, the the weight issues, like what were the major challenges to your design?
The major challenges is actually trying to find all the technologies and materials that would be needed for this project, because some of the technologies I did not even know existed until I did this project.
Right.
And the research itself took me months to finish. It took me longer than the model to make the model. So I had to go and actually try and find them, and like finding one piece of information that isn't this might be considered insignificant to one person, but was important to this project, took me at least 5 days to research. So every little detail took a lot of time, and I had to do a lot of math calculations in order to find, okay, this is about how much energy output at this speed, at this altitude, according to this equation, and things like that.
Do you think the dirigible idea is a real practical, like is a practical solution for some of these energy problems in certain areas?
I believe so, because windmill farms have a lot of, not only that it's not very efficient, it's just that also has a political issue that people don't like it because it's just an eyesore to a lot of people, and it's noisy, and they don't like that around their houses. So if this is in the sky, like thousands of feet up, you're not going to really hear it, and you're not going to see it all the time. It's maybe just like a speck in the sky. So it might help with that political issue, as well as I try to address a lot of the cons of the other airborne turbine designs that I found, like some safety hazards and things like that. Things that, the other designs haven't really considered as a con that I found.
Yeah. I think the only thing that is a potential con for your design is the fact that we're running out of helium.
Yeah, that may be one of the issues, but America and the U.S. has been known for its a lot of supply of helium. So, I hope to at least get it while the cost is down for helium.
Right, absolutely. So how has this week been for you? Has it been exciting and something new?
It's totally something new because this is my first time at ISEF, and it's been exciting, nerve-wracking. Yeah, I've just been on a roller coaster of emotions because one minute I'll be like really happy, then the next I'll be like super nervous and scared, and then one moment I'll be like angry because I can't remember something, or I would think I forget something, and the next I'll be, back to happy again. So it's just a roller coaster of emotions. But it's been a great time.
You've been having a good time. That's good.
Yeah.
Are you excited about the finals, the awards announcements tomorrow?
I'm not really too concerned about that because I don't really care what happens. I was surprised to even make it to ISF because I didn't think my project had that much potential.
Wow.
And I didn't even think I would go to my state science fair. So I was just like super stoked when I was told that. So to me, this is more of a learning experience and making new friends and getting connections around the world and trying to promote my science fair project because I need kind of like funding for my next phase.
Yeah.
So I just want to stoke this out.
Have you patented the design? Is this something that you've worked on?
I'm trying to patent it, but it's going to take a while for me to patent it because I have to go through the whole process of patenting it and get the money for the patent. So,
right, yeah, that's always the process. Well, good luck with that. And are you going to go? What's your plan? You're in 10th grade, right? So you've got a couple more years of school and then you move on to college. Are you planning an engineering future, a science future? What are your plans?
Actually, I'm wavering now because originally I wasn't going into science until I actually started getting really into science fair. Mm-hmm. So I was originally going to go into more of the art side because I've been with art since my early childhood and I just love art. So graphic designing became part of me, but then I learned that, okay, engineering is pretty cool too. So I started looking more into that too. So I'm trying to find a career that maybe can integrate both sides, art and engineering.
Yeah.
Because I love.
You love both of them. Well, good luck. I wish you the best of luck in your future. And with projects like yours and an imagination and the ability to put things together the way that you do, I mean, there's a lot of promise for whatever you do. So good luck with that, and good luck in the awards ceremony. I know you don't really mind either way what happens, but it's always fun to hope. So,
yes. Thank you.
You're welcome, and I hope to speak to you again someday. Maybe. Take care.
Yes. Okay. Thank you.
Thank you very much. Bye, Kelsi. And that was Kelsi Watanabe from Hawaii, and her project was a dirigible blimp wind production device. And we have now another student, I believe. Is this Olga?
Yes.
Yes.
This is Olga.
Great. Hold on 1 second. How are you, Olga?
I'm doing pretty good. How are you?
I'm doing great. Thank you for talking with me today. I'm very excited to be able to talk with all of you students who are here visiting. What grade are you in, and what's your school?
I'm a senior at Health Careers High School in San Antonio, Texas.
Excellent. I'm sorry, I've got your lower third wrong, I realized, so I'm trying to fix that. Come back. There we go. Okay. Got your name right at least. Here we are. So tell me about your experience so far this week. How's it been going for you?
It's been really fun, but more so than fun, it's been an honor. I met some projects that are the best, not only in the states of the United States, but actually some of the best projects in countries. So that's really been an honor, and it's been really exciting to learn about all these people's projects and to meet all of them.
Was it an arduous journey from Texas to California?
Yes, it's a big change, definitely. It's not only in the climate, it's a lot colder up here, but it's a different place.
Yeah, a very different place. So your project, tell us a little bit about what brought you here and what got you to the fair.
Well, my project is entitled Novel Role of PARP4 as a Potential Target in Breast Cancer. And actually, I wasn't planning on doing science fair before, but I decided to later on, right before the regional paperwork was due, and that's when I kind of started doing it. But before that, I kind of grew up surrounded with the medical field. My mom was a doctor when I used to live in Russia. I actually immigrated over here with my mom and my brother in 1999. And so I continued to grow to be raised in a family that was very surrounded with both medicine and my dad, who is a patent attorney here, the technology side of things kind of raised me surrounded with science.
And so the science that you are most interested in, is it the in the, I guess, the genetics, cancer, medical field? Is that where you're most comfortable right now?
Well, actually, I want to go into cardiology. This just happened to be an opportunity that I received to work in cancer research. Mm-hmm.
Okay, so tell us exactly the gene that you were looking at, and what exactly your project determined.
Okay, so PARP4 is a protein that's naturally present in our body. So there's a gene coding for the production of it. And PARP4 stands for poly-ADP ribose polymerase 4, and it's in a family of PARP, which has 8 isoforms. Now, there's not a lot of information out there about it. Each protein has its own different structure and function. Mm-hmm. And it was actually found to be in colon cancer cells, and I thought that it would be present in it was found to be present in breast cancer cells, and I thought that it would contribute to the breast cancer cells' ability to grow and migrate.
And
well, it does. From the data that I've collected, one of the tests I performed was the migration assay, and it actually envisions the cancer's ability to travel to an unoccupied region. Okay. And in this test, the protein made the cells migrate. When the protein was overexpressed in the cells, then the cells migrated 50% more, which is a huge difference.
Wow! Mm-hmm. So you infected these cells with different amounts of the protein, and if it was not infected the cells, but if they had more of the protein, they migrated further.
Exactly, because the protein is naturally present in the body in both non-malignant and malignant settings, and however, there's more of it expressed in the cancerous cells, and I overexpressed the protein in those cancer cells, and that gave and compared the ability of the cells to migrate, to form colonies, to invade, compared the cells of the regular cell line versus those of the same cell line overexpressing the protein PARP4.
Wow. So what are your conclusions from this, and maybe your ideas for how this could influence cancer research?
Well, actually, I performed another test, an invasion assay, where the same sort of results were seen. There's a lot more invasion when the PARP4 was overexpressed. Mm-hmm. And I added another, experiment into that one, where I inhibited the PARP4 gene by using short interfering RNA. So PARP4 protein was no longer produced in that cancer cell line, and that actually reversed the effect. So this kind of brings me to thinking that if PARP4 is inhibited in the body of a live organism, then perhaps the cancer cell's ability to grow and migrate would be decreased sufficiently.
Right, and so then possibly you have if there's going to be any kind of metastasis, you can limit that probability.
Exactly, yes. And the next thing that I'm actually working on is performing this in mice to see what would be the effects of inhibiting a gene, because you can't just inhibit a gene and expect no negative effects to be there.
Right.
So, mean, if the positives outweigh the negatives, then the next step would be to look at a clinical trial and see if how this could be used in treatment for humans with cancer.
Yeah, that would be really interesting. From the mice, I mean, when it's like you said, it's a protein that's expressed in lots of cells. So exactly. If it's expressed in lots of cells and you get rid of it in lots of cells, what other effects are going to happen?
Yeah, see, that's something that's unknown right now, because all of its functions aren't even known. I believe, from as far as I know, they don't even know the protein structure map for that particular protein yet. And one thing that I was thinking of is this protein was found to be present in colon cancer cells. Yeah. And so I was thinking that if it is present in those cells, it might also be present in other cancer cells as well. So not only would using using inhibition to inhibit the production of the protein would decrease breast cancer metastasis, but it may actually reduce other types of cancerous metastasis as well.
Which would be huge. That would be pretty awesome.
Exactly.
So do you really enjoy your research? Are you a lab rat yourself?
Yes, I am. I know actually how I got kind of started with this project in particular was there's a program at my school called Scientific Research and Design where we have block schedules. So we have 4 classes a day. And for every other day, I'm allowed to leave school at noon and stay through 4 o'clock and go to the lab and conduct research. And I was at the UT Health Science Center in San Antonio. And so I would go there and, do all my work. And I know a lot of people would kind of skip out on the lab or go to the library and go do their homework or leave early. And I know I would always go to the lab and get as much done as I could because it's really fascinating. And I didn't think that I would have something this huge on my hands.
Yeah. The surprise aspect of it, was that something that they always talk about, the aha moment of science? Did you have an aha moment?
Yes, I definitely did. I know when I first started working on it, I didn't expect anything to come from this. I was just going to the lab to learn because I thought it'd be a great experience, and it definitely was. And I was just working on something that I thought, okay, well, this will give me practice, and so if I need to do this in the future, I'll be able to do it. And that's when I realized, well, this could actually have very high potential, and that's how it got me this far in the science fair.
That's fabulous. And so what do you plan to do with your science? You said cardiovascular physiology is what you're interested in. So are you going to medical school, PhD? What are you thinking?
Yes. Next year I'm actually going to be going to Texas A&M, and I'm going to be studying pre-med biology and Russian. Well, because I am from Russia, so that's always something interesting for me. And after that, I am looking at medical school. And I know there is this one program where you can get actually an MD and a PhD, and it's a 6-year program that I was looking at. That's always an option for me if I don't want to just stick to the clinical side of things. Yeah.
And so moving forward, as you go on forward, there are going to be lots of other students who are going to be coming up with projects and trying to get into, move and get to the Intel Science Fair.
Exactly.
Do you have any words of advice for any aspiring younger scientists?
I guess mainly just stick to whatever you're doing, even if it seems really hard. I know I'm so thankful for the lab that I got to work in, even though at first I thought that things would be really tough with my mentor, and being able to having such a huge responsibility on my hands. But if you just stick to it, then there really is very rewarding things at the end.
Absolutely. Thank you so much, Olga. It's been
thank you.
It's been great chatting with you. I wish you all the best in the competition. I know that not everybody I spoke to today can win, but I have my fingers crossed for all of you, and I also believe that you will all go very far in your lives. So keep on working, and thanks for doing science.
Thank you so much.
Thank you.
Bye.
Bye, Olga. And now, I don't know, I believe Wendy Hawkins is going to join us, but I'm not sure. So let me have a brief word from our sponsor before we move forward. This hour of Dr. Kiki Science Hour is brought to you by Squarespace. Squarespace is the fast and easy way to publish a high-quality website or blog. For a free trial and 10% off of your new account sign up, you just have to use the promo code Kiki. So you go to squarespace.com and use the promo code Kiki, and that'll get you 10% off of your new account. Squarespace has easy to use user interfaces for creating and managing websites and blogs, optimized for beginners and experts at CSS. So if you're an expert, you can customize it to your website to your heart's content. If you're a beginner, there's a lot of plug and chug, WYSIWYG kind of stuff going on. You can make a very nice blog without knowing too much technical stuff about web design. There are all sorts of modules, and it's an all-inclusive service, and they have various levels at which you can subscribe. So for a free trial, or once again, if you are interested, you don't need a credit card. You can just try it out. You can get a free trial. But if you decide to purchase, 10% off, squarespace.com, use the promo code Kiki. Miss Hawkins, Mrs. Hawkins, Dr.
Hello.
Hawkins. Welcome.
Mrs. All of those will work just fine.
Executive Director Hawkins.
Oh, I like that one.
Yes, that's good. Thank you so much for joining me today on the Science Hour. I would love to hear how your experience this week at the Intel International Science and Engineering Fair is going.
Well, it's a fabulous week, as it is every year. I'm always so thrilled to be here with these students who are a combination of absolutely amazing brilliance, hard work, and great fun, great energy. It's very energizing to be here. I have a cold and I feel terrific.
It's good that that kids can give you that much energy and inspiration. There's so often recently. I mean, I work in science media and I see great things happening across the United States in science. But there are a lot of people who are talking about the state of science education in America today, and where we're going is a downhill path. Do you agree?
Well, I don't really agree, partly because it's this week.
Yeah.
You look at the data and you look at the statistics, and I'm always concerned, both for our country, because I think science and math and engineering and the study of those subjects is absolutely critical to our future and the future of any country.
Mm-hmm.
That's where innovation takes place, and that's where new jobs are created, and that's where new ideas that are going to solve these huge problems that we're handing on to this next generation will come from. And so when you see data that look like test scores aren't as high as we would like them to be, where you see not as many students as we feel would benefit from pursuing these areas are going into the technical fields, not as many as we might hope to be able to hire are coming out. All of those are a worry. But you walk onto this floor and you see 1,600 students who have done work at age 14, 15, 16, 17 that would qualify at many universities across this country for PhD thesis.
Right.
And 25% of whom have applied for patents on the work that they have done, the original work that they have done. And you talk to these kids and you see the passion and engagement they have for doing real work, real science, real engineering to solve important problems that are meaningful to them. Suddenly you give this big sigh of relief and you find your centered place and you think, things may be okay after all.
I can agree with you there. So what is Intel's role? As you know, I know it's the name sponsor, but it goes beyond that. And as the executive director of the Intel Foundation, can you give us a kind of broad view of what Intel is doing with stuff
Sure.
like the science fair?
Yeah, I always warn any organization that's going to get a grant from us to be careful what they ask for, because we don't just show up with a check and walk away.
Right.
We roll up our sleeves and are very, very involved and engaged in the design of and putting on the program. We work very closely with our partners at the Society for Science and the Public for many, if not all, of the decisions that are made about how this program is run. We care deeply that the students who come here have the peak experience of their lives up to this point, and we hope that they carry these memories with them. We want this to be the beginning of their embrace within the science community. We want them to build an international network here that will be the basis on which they build their connection into the scientific world. The scientific community is so international, it just doesn't see national boundaries as being very meaningful for ideas. They just flow all over the world. I'm married to a scientist myself, and I know that that international community of scientists is very real, and this is the beginning for these kids. This is what I want them to walk away with. And then I want educators and decision makers and government officials from around the world, and we bring many of them here and speak to many others. I want them to see this as a beginning point, inspiring them to change the opportunity and experience for kids in their schools, in their countries, so that fewer and fewer kids are learning science from lectures and by reading and memorizing texts, and that they're not put off by the fact that they're not allowed to actually do any real science until after they've learned all of the facts and figures and formulas. I want them to have the chance to roll up their sleeves, do real and authentic work that is very exciting and meaningful to them, and to then say, wow, if I learn this new thing, then I'll be able to solve that problem. And, oh, look, there's a piece of this problem that I still don't know how to solve. But if I go study that subject, I'll know some more about it. I want that to be the way students approach science.
What do you think has to happen for that to be reached? Do organizations, corporations like Intel need to get involved in a donation of time and people and money? Is that what needs to happen, or is it more? Do you think more local governmental kind of actions, school board kind of actions?
Oh, I think it's all absolutely critical that all of us step up and do what we can and are best suited to be doing to solve the problems and meet these challenges. Businesses, companies, especially high-tech companies like Intel, have the unique capability of showing these students exciting real-world applications for the work that they have that they will be doing. And there are any number of fields and any number of businesses that have the ability to give students those experiences, to connect them with real working scientists and engineers who can coach and advise and supervise the scientific research that they're doing. And I think especially a company like Intel, high-tech companies are driving change so fast in the world in which educators are trying to operate that it's an unfair thing to ask of a teacher to keep up with those changes on a daily basis unless we reach out and help. But then there are the basic decisions about how education is funded and what the standards and assessments will be. Those are decisions that businesses don't make, although we can add our voice to the discussion and be advocates for where we think things should head. But those are really decisions that have to be made by the educators, by the governments, by the school boards and ministries of education around the world. And so they absolutely have to do their part to give these kids the education that will really prepare them for the world that we're helping to create, both in bad ways and in good ways.
So this week is a really special week. I'm sure all the students who are there are just so excited to actually have made it to this international.
I'm not bouncing off the walls.
Boing, 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 boing. Yes. What are they competing for? What are the awards at the end of the week that tomorrow will be announced?
Well, some of the awards, in fact, will be announced tonight. There's $4 million in scholarships and awards that will be handed out. Tomorrow is the big award ceremony, but tonight is the special award ceremony. And there are hundreds of awards and scholarships that these students are competing for. The top award is a brand new award that we're funding for the first time this year. It's the Gordon E. Moore Award for the very top student at this competition. Gordon Moore was one of the co-founders of Intel, and we're terribly proud to be able to honor him and the transformative science and engineering that he brought to the world by recognizing a student with this $75,000 scholarship. And then two students will receive the Intel Foundation Young Scientist Award, and that carries with it a scholarship for $50,000. So two students will receive that. There are trips to Sweden to go to the Nobel ceremonies. There are trips to Europe to compete in the competition there. Students will travel to Taiwan and compete in the competition there. There are scholarships offered by the military, by universities, by other companies. So there will be a lot of smiling faces when all these kids go home.
Yeah, I can absolutely believe it. And I read on your blog from, I believe, January-ish, after it was, I believe you said that there were last year's finalists, a couple of the winners were actually sitting next to Mrs. Obama
That's right, at the State of the Union address.
Yeah.
One of the young ladies who was one of the top award winners here at Intel ISEF, and one of the finalists from the Intel Science Talent Search, another competition we sponsor, were the two young ladies that sat with Mrs. Obama at the State of the Union. Made us very proud, and I can tell you they were pretty darned excited too. And I think Mrs. Obama was pretty pleased too.
I'm sure she was very pleased, very excited to have that moment of getting to meet these young women who are today's and tomorrow's scientists.
They're pretty amazing.
Yeah. Do you think that with the push from the White House as well, I think there's and this competition, do you think that we're really rolling into a new? I don't know. I feel that we're rolling into a new era of science education and excitement and involvement. Do you feel that?
Oh, absolutely. I'm very excited about the commitment of this administration to science and math education. They really are putting a full court press on it. It's clearly a priority for the president. We enjoyed taking the 40 finalists from the Intel Science Talent Search to the White House to meet the president just a few weeks after he was inaugurated. And he made time to spend with the kids and talk with the kids then, clearly made it a priority. Secretary Duncan has it at the very top of his priorities for the education system nationally. But as you know, the federal government can provide a bully pulpit. They can provide inspiration. They can provide some incremental funding. But the bulk of the dollars that fund education here in the United States are local and state dollars. And we work with the National Governors Association, and we work with the education leaders in the states and communities where we have a presence. And it's at that local level where the rubber hits the road, and a lot of these decisions that will affect these kids and their ability to pursue their dreams and to provide solutions to the great problems of the world, whether it be global warming, illnesses that are not yet cured, any number of problems that these kids will take on. That's what we all need to provide the support for.
Yeah. Do you see, is there any discrepancy between areas that have lots of funding and those that don't in terms of representation at this kind of a science fair?
Oh, you certainly see that communities that make this a priority, whether they are rich communities or simply communities that have dedicated their resources to support kids, and they have built up fairs, they have dedicated resources so that students are taught in class how to do research, where the community has rallied and provided mentors from, whether they're from the university or whether it's the local veterinarian and forestry service agent, that money isn't the sole determinant by any stretch of the imagination. Money certainly helps, though.
It does certainly help. Do you have any words of advice to future Intel Science Fair participants?
I would say that the most important quality that I see in the work that the students who are successful here is passion and following their own personal dreams and interests. So the advice would be to find a subject that really energizes you, excites you, to ask important questions that nobody else has asked. The wonderful thing about research is that when you've done some research, and really found out what you were seeking, you're the only person in the world who knows what you know for that first few moments. And it's such an exciting mystery to be able to solve. So make sure it's a question that's important, that you feel good about answering.
I think that's some pretty good advice. Thank you very much for being my guest here on the Science Hour today. I appreciate your time. I'm sure this has been a very busy week for you. So Before you go off, I just would like to also say thank you to Intel for sponsoring and being a part of the science fair, because I think it's really doing a good thing for science everywhere. So thank you very much.
Thank you. It's been my pleasure.
Thanks. And that was Wendy Hawkins. She's the executive director of the Intel Foundation. Thank you. And this has been the Science Hour. We've had so much fun. I've had, let's get the right lower third up here. The lower third buttons are going too slow today. It's episode 46, The Future of Science. And I believe the future is bright. Looking at everyone who I got a chance to speak with today and what they've done in just a couple of short years in high school. Let me repeat, high school. The naysayers about whether or not we're going to be able to solve problems in the future, I don't know. I don't think they're that right. I think we have a brain trust. We have the children of today who will be solving those problems, and they're already working on it. So just take a look around you and see what's out there. I also would like to thank Keisha Cochrane for helping me set up today's interviews. It was only with her assistance that I was able to do this today, and she was an integral part of it. She works at Intel in their PR department. And I'm Dr. Kiki, and this has been the Science Hour. Next week, we're talking about the Large Hadron Collider with Anil Ananthaswamy from New Scientist magazine. Ask us any questions you like. Please send me any questions that you have about the Large Hadron Collider. Send them to Dr. Kiki at twit.tv. That's Dr. Kiki at twit.tv. Send me any questions related to the Large Hadron Collider, and hopefully we'll be able to get to them. We're going to try and do an overview of what's going on in the Hadron Collider, what's happening, and what's not going to happen. So I'm going to try and educate some peoples out there. That's what we're trying to do. What else is going on? Not much else. Until then, you can follow my science-y pursuits online, my pursuits of science information. You can find me anywhere if you just Google Dr. Kiki. I'm Dr. Kiki on Twitter. I have a Dr. Kiki Facebook page, but, Leo just quit Facebook, so I don't know how long everyone else is going to be there. Anyway, and you can subscribe to the Science Hour if you go to twit.tv/Kiki. If you need more sciencey goodness, This Week in Science is also on the Twit Network now Monday nights from 8 to 9 p.m. Pacific time. If you just need another dose of science in a different way, that's me and Justin and our intern Allie, and we talk about science news for an hour once a week. I will see you next week. Thank you so much for joining the Science Hour. All I ask, really, is 1 hour a week. And, it's not just one Science Hour. It's your world.